Now we will start with the properties of adjoint. The first property of adjoint. The first property of adjoint, it's adjoint AB is equal to, you to write in the reverse order, adjoint of B and then adjoint of A multiplied. Now adjoint of A transpose is equal to adjoint A whole transpose. This is the property of adjoint, second property. Now for inverse, the first property is A inverse of inverse. You will get back A. Then you have A transpose inverse is A inverse transpose. The third is AB inverse. Again, you have to use the reversal law. B inverse A inverse, sorry. B inverse A inverse. Now let us take a problem and let us understand how, let us find an adjoint and everything. Let us take a problem. Now the problem is you have a matrix A given as 1, -1, 1, 2, 1, -3, 1, 1, 1, and then you need to find A inverse. Find A inverse. Then you have to solve, and using A inverse, and then I should say solve x plus 2y plus z equal to 4. You have minus x plus y plus z equal to 0, and then x minus 3y plus z equal to 2. Now see, before, what is the formula of A inverse? A inverse is to be written with adjoint A by determinant A. This is the formula of A inverse. Now let us find the determinant. A determinant, that means you put this two lines and then 1, -1, 1. You have 2, 1, -3, and then you have 1, 1, 1. Now you put the signs as usual, plus sign and a minus sign and a plus sign, and expand. You have 1, you hide the first row and the first column. You hide it. So what you have got, 1 into 1 and -3 plus 3. 1 plus 3, sorry, we'll use this color. 1 plus 3. Now you hide the second column. You hide the second column. Wait, let me rub this also. Yes. Now you hide the second column. Now when you have hidden the second column, now minus into minus, this minus and this minus. This will give you plus 1, and then you have 2 into 1 and this. 2 ones are 2 and plus 3. Now you have plus, now you have to hide the third column. Wait, let me rub all this. Let me rub all this. Let me rub this. Let me rub this. Let me rub this. Now you have to hide the first row and the last column. Now what you are left with is plus 1, 2 minus 1. Now this is 3 plus 1, 4, 5 and 1. That is 9 and 10, which is not equal to 0. Hence, you have to write, hence, A inverse exists. A inverse exists. Now to find, I will show you a shorter method to find adjoint A. What you do is that write the matrix A. Again, you write the matrix A here. A is what? 1, -1, 1, 2, 1, -3, 1, 1, 1. This is given. So what you do is that you write the matrix 1, 2, 1, -1, 1, 1, 1, -3, 1. Repeat the first two columns. 1, 2, 1, -1, 1, 1. And now Wait. Now you repeat the first two rows. 1 minus 1, 1, 1 minus 1, 2, 1 minus 3, 2, 1. This you repeat. Now what you do is that, wait, let me rub this. Now do is that, cut the first row and cut the first column, right? Now what you do is that, see, I'll write directly adjoint A. I'll write directly adjoint A, the shortest way. Now you see how to write directly adjoint A. Do one thing. Multiply this and this. 1 minus 3 is plus 3, that is 4. This is straight 4. Now what you do is that, let me rub this. Now you take this 2. This is 1 and minus 1 minus, that is plus 2. This is plus 2. Plus 2. Now again you rub this 2. Now what you do is that you multiply this and this. 3, because minus 1 minus 3 is plus 3, and then minus 1, that is 2. So you write 2 here. Now rub this. Now come to this. You multiply, just a minute, multiply this 2, multiply this, minus 3 minus 2, minus 5. Minus 5. Now you rub this. Now you take this 2. 1 minus 1, that is 0. Now you rub this. Now you take this, multiply these two, this and this. 2 and plus 3, that is again 5. Now you rub this. Now you take the last 2. 2 ones are 2 and 1 ones are 1. 2 minus 1 is 1. Now you rub this. Now you multiply these two. Wait, multiply these two. This is minus 1, minus 1. This is minus 2 now. You know how to multiply these type of things. Now you multiply this two. 1 plus 2, that is 3. This is how you find the adjoint in a very short manner. This is how you find the adjoint in a very short manner. Now I'm going to rub this line, this line. No, let me keep them because this is your working. Let me be there. Let it be there. Now let's come to A inverse. Let's find A inverse. We already have adjoint A. We already have adjoint A. Let's write A inverse. Let's write with this. A inverse is, let's write the formula, adjoint A by determinant A. Determinant was 10. So 1 by 10, write down this matrix. 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3. Now you have to do is, now solve this. You have found A inverse. Now you need to solve this equation. See, the equation was given as x plus 2y plus z equal to 4 minus x plus y plus z is equal to 0 and x plus minus 3y plus z equal to 2. Now this is of the form ax equal to b. Now write it that way. This is 1 minus 1, 1, 2, 1 minus 3. Then you have your 1, 1, 1. And then you have your x, y, z. Then you have your 4, 0, 2. Now, in order to get x, multiply by A inverse both side. A inverse both side. But the thing is this, if you see this matrix, this A matrix, this is nothing but the transpose of the above matrix. This is, if you see this matrix, this matrix, let us call it A1. A1, let me rub this first. First, let me rub this. This A1 matrix, A1 is basically the transpose of that matrix. So let me write it here. This is A1. A transpose X is B. Now I will take inverse on both sides of A transpose. A transpose whole inverse, I'll multiply by this. A transpose X is equal to A transpose whole inverse b. So this will become identity. So an identity into x, and this can be written as by the using the property of inverses, this property of inverse, this second property of inverse, this can be written as, A inverse transpose, whole transpose B. So X comes out to be, you have found A inverse already you have taken, and take the transpose of that. Transpose of that would be 4, 2, 2, then you will have minus 5, 0, 5, and then you will have 1, minus 2, 3, and then your B is 4, 0, 2. What I did was that my A inverse, see, my A inverse was this. A inverse was this. I wrote this row, this row in form of column, this row in form of column, and this row in form of column. Here, you can see this. Here, you can see this. Here. This has now become a column. This has now become a column. Now do is that multiply this with this, multiply this row with this column, multiply this row with this column. Now I'm going to do that. Let me rub these lines. Now see, this is going to become 1 by 10. 4 fours are 16 minus 0 plus 2. That is 18. That is 18. That is 18. And then 2 fours are 8. 0 into 0 minus 4. Minus 4. 8 minus 4 is 4. And then 2 fours are 8. 5 0 0. 3 twos are 6. 8 plus 6 is 14. Now what I do is that divide, I multiply the whole thing inside this by 1 by 10. So this becomes 18 by 10, 4 by 10, and 14 by 10. So this becomes 9 by 5, this becomes 2 by 5, and this becomes 7 by 5. So your x, so this is your x, that means your x, y, z, is 9 by 5, 2 by 5, and 7 by 5. So with this, we have, this implies small x is 9 by 5, small y is 2 by 5, and z is 7 by 5.